Okay, today in class we talked about waves, and tonight your homework is to go further into waves and look at electromagnetic waves. I have given you a set of notes for you to follow along and fill in the blanks. Please make sure that you do that. We're going to talk about the electromagnetic spectrum, the different parts of the electromagnetic spectrum, which will bring us into focusing on specific waves that will help us in our astronomy unit. Electromagnetic waves are transverse waves. We talked about transverse waves in class. Transverse waves have the crests and the troughs, and they have some electrical and some magnetic properties, but they consist of changing electrical and magnetic fields. And you can see in the diagram the different types of fields that are there. It shows you the electric, it shows you the magnetic, but if you look at the animation here, you can see the electric field is in blue, the magnetic field is red, and you can see how there's that consistent changing. You can see the direction of the waves. It shows you the arrows and how in one section of the wave the arrows are pointing up, and another section of the wave the arrows are pointing down. It's because those two fields, the electric field and the magnetic field, are constantly changing. Electromagnetic radiation is the energy that is transferred by electromagnetic waves. It does not need a medium to travel, so you can travel through vacuum of outer space. Remember, we talked about mediums, and mediums are what waves would travel through. If you were to think of a rope and you were to cause the rope to move up and down, then the medium that that wave is traveling through is the rope. The electromagnetic spectrum is the name given to a group of energy waves that are mostly invisible and can travel through empty space. You see here in the picture that you start with your radio waves, and as you move across, you go all the way to your gamma rays, which are the smallest waves. They are placed in order of increasing frequency. Frequency, remember, is like speed. It's how many waves travel a certain past a certain point in a given amount of time. So you can see, starting over there to the far left, that these have the longest wavelengths and they have the lowest frequency. There's not many radio waves that have a short frequency. So these are far to the left, and then as you move across to the right, the waves with the shortest wavelength, known as gamma waves, have the highest frequency, and they are on the right. But all the waves are going to travel at the same speed. Radio waves have the lowest frequency, the longest wavelength, and radio waves will transmit radio and TV signals. The radio station that you listen to broadcasts at a different frequency. That's why you have those numbers that you change to the FM channel. And the number of the radio station tells you the frequency it broadcasts at. So if you listen to 93.3, that radio channel will only broadcast with waves that have a frequency of 93.3, which is why you don't have a radio station that has that overlapping sound between two radio stations. You've got 93.3, but then on the other end you've got 106.1. That has a higher frequency. So the radio station of 106.1 will be dealing with only those wavelengths with that frequency level. Microwaves are still radio waves, but they have a shorter wavelength. Microwaves you probably all have in your homes or in your apartments. And what happens is you have these radio waves that interact with the water molecules in the food. And then when they interact with the water molecules in the food then absorbs that energy from these microwaves. And when it absorbs the energy, the food gets hot. They are also used to transmit cellular telephone messages. Every time you talk on your cell phone in areas where there is not a cell site, you can see cell phone towers, and then you can see these old, really big pieces of metal. They're located right here. You can see those kind of towers as well. When you're in areas out in the country that don't get all the digital information, don't have all the chances to have digital TV or whatever, they use those type of cell sites, and those are the sites that'll transmit your cellular phone messages. Infrared waves have a shorter wavelength and a higher frequency than microwaves. And infrared waves are heat waves. So you can feel it when you stand by an electrical stove, by a toaster, or heat lamps. You can see the coils get hot and you can feel the heat that's given off. Hot objects will give off infrared waves as well. If you watch the show Ghost Hunters or Ghost Adventures, they talk about infrared cameras that'll pick up heat signatures. When a person walks in front of the camera, the color is shown as a bright white, a yellow, reds and oranges really bright, whereas those that are cold, that have areas that have cold temperatures that are not alive, like an inanimate object like a chair or a table, when the camera's facing that, it's going to be the darker blues and purples because that's not giving off a heat signature. Excuse me. Visible light. This is the only kind of light or wave from the electromagnetic spectrum that we are able to see. Shorter wavelength, higher frequency than infrared waves, and they can be seen as colors, and we know this to be visible light. And white light is broken down in the rainbow set of colors. We know this, we use an acronym called Roy G. Biv, R being red, O being orange, Y being yellow, G being green, B being blue, I being indigo, and an indigo is a combination of blue and purple together, and then V being violet. And when you come to class tomorrow, I'm going to give you a pair of glasses to look through, and you'll be able to see the breakdown of the colors from the white light in the classroom. So your visible light that we see is our spectrum of colors. When you look at a rainbow after the rain and you see the light from the rainbow, you'll see the colors in that order. And we'll talk a little bit more about visible light in these Roy G. Biv colors when we deal with spectroscopes and the flame test lab. Ultraviolet light, we don't see it, but we see what happens when you're outside too long with ultraviolet light. Shorter wavelength and higher frequency than visible light. Ultra is Latin meaning beyond, so it's just appropriate that ultraviolet means beyond violet. Violet light is the very last color of the visible light spectrum, so this is beyond violet. It can kill or damage living cells. Too much exposure to UV rays can cause skin cancer, and there's different types of UV rays. Scientists are finding now that it's better to not just protect against UVA, but there's UVB rays, and so we have different companies that create different sunscreen, and the sunscreen is just supposed to give you a little bit of a protectant layer and let those UV rays bounce off of you instead of soak into your skin. It allows you to be outside a little bit longer than normal. Small amounts, though, of UV light is good because it will help your skin cells to produce vitamin D, and that's necessary to produce healthy bones and teeth. X-ray radiation has a shorter wavelength and higher frequency than the ultraviolet light, and X-rays will pass through the skin, but it will not pass through the bone. So bone starts to absorb the X-rays, which is why when you get X-rays, if you ever go in for an X-ray for something that you might think is broken or fractured, when you see through an X-ray, you see the bones. It's because the bones have absorbed that X-ray radiation. That's why they appear white. The skin and a lot of times the tissues around it does not absorb those. It just lets it pass right through, which is why that looks black, which enables the doctors to see if there's a break or a fracture in any kind of bone. Too much of this is harmful to humans, which is why when you go into the dentist, they put these big blanket type things on your body to protect you when they take X-ray pictures. It's why you see the nurses and the specialists and the doctors step out of the room when an X-ray is taken because too much is harmful to humans. The last type is your gamma radiation. Gamma radiation is a shorter wavelength. It's the highest frequency of all the electromagnetic spectrum, and it is the most penetrating, which means it has the most energy of all the electromagnetic waves. Some radioactive or nuclear reactions produce gamma rays, so the stars out in space We're able to get information by looking at gamma rays. They are harmful to humans, but in controlled substances they can be used to kill cancer cells. So these are the different types of wavelengths that we deal with when looking at the electromagnetic spectrum. Our main focus is going to be on light waves and radio waves, because it's these two types of waves in particular that astronomers look at to determine distances and properties to and from components in the universe like galaxies and stars and other planets. Now that this is finished, I want you to do the summary at the bottom. Summary is like always, the 2 to 3 sentences. But I want you to include 3 facts in that, and if you do have a question, please add your question down at the bottom of the notes, and we will make sure we discuss that question tomorrow in class.